Alright, so now that we're in our ISN, we're on page 29, and we're going to be doing a lot of writing in this lesson. But first, let's draw a diagram. Let's draw a coordinate grid, and let's just draw an acute angle for right now. So there's an acute angle theta. You can see our initial and terminal sides. But now I'm going to tell you a few more things. So first over here we're going to write let theta. Let me darken this a little bit. Let theta be an angle in radians. I'm sorry, in standard position. Maybe I should look at my notes. Let theta be an angle in standard position. We're also going to put a point on our diagram, and we're going to call that point P. And point P is going to have coordinates of x and y. So over here we're going to say let P equal x comma y be a point on the terminal side of theta. Okay, so we've got our theta, we've got our point P. And there's a couple of things I want you to notice here. Because of that, we can actually draw a triangle. This is a triangle. And let's think about how long this leg is here, this bottom leg. Well, since we're in a coordinate grid, and this point is right here, and its x value is x, then that means that this side is actually x units long. Also, we can see that the y value of our point is whatever y is, so the side length of this triangle would also equal y. So it's x units long on the base, and it's y units high. And we know that because of the values given in our point P. Just to kind of make that a little bit more clear, I'm going to highlight those values, where they come from. So this height comes from the y, and the base length comes from the x value. Okay, now that we have two sides to this triangle, is it possible to find the length of the hypotenuse? Well, hopefully you guys realize this is a right triangle, and we can do that using the Pythagorean theorem. So let's call this length here, instead of calling it h or something, let's decide to call it r. And so we can find r by doing r squared equals x squared plus y squared. That's the Pythagorean theorem. The hypotenuse equals one leg squared plus the other leg squared. So if we were given a point, then in theory we could find r by finding the square root of x squared plus y squared. All I did there was square root both sides to get r by itself. So now, no matter what my point is, I can find the hypotenuse using this little formula. So over here, we're going to state that. We're going to say let r equal the square root of x squared plus y squared be the distance from 0, 0 to x comma y. So we kind of have like three statements here about this diagram. We have an angle theta, we have a point P. Sorry, my phone's ringing. Tori, I'm doing a video right now. Bye. That's my husband. So anyway, so we have 3 points here about this diagram. Now, the whole reason why I went into detail about this diagram is this is what we've been working with all along, an acute triangle. So if I told you to find the 6 trig ratios of this triangle, you would be able to do that. You would know that our theta is right here on this inside. Let me just zoom in on that. So our adjacent side is x, our opposite side is y, and our hypotenuse is r. So if we were given a point, we could plug into this formula to find r, and we could say sine of theta is equal to whatever x is over our r. We could say cosine equals our y. I'm sorry, I did that backwards. Sine is y over r. Cosine would be x over r, and so on and so forth. If you can understand what I just said right there before I messed up, then you'll be able to understand what's going on in the rest of this lesson. Because basically we're going to draw the same triangle, but in the other 3 quadrants. So below that, go ahead and draw 3 more coordinate grids. Alright, so our first one we're going to draw in the second quadrant. So there's our terminal side, our initial side, our angle theta. So let theta be the angle in standard position. We're going to let P be a point, x comma y. And that's going to allow us to state that the base of this is x units long and the height is y units tall. And we know r because of this formula. Okay, and then we're going to do the same thing over here. Now we're going to go to the third quadrant. Draw our terminal side, our initial side. Theta is here. Let's put a point. We're going to let a point P equal x comma y. Remember, x and y just stand for any numbers in that quadrant. That means that we have a height on our triangle of y and a base length of x. And the hypotenuse can be calculated using our formula and give us r. One more time, all the way around in the fourth quadrant. Same thing. There's our terminal side, our initial side, theta. We're going to plot a point P, and it's going to be called x comma y. That creates a triangle for us where the height is y units and the base is x units long. If we know the height and the base of the triangle, we can calculate r using the Pythagorean equation that we have over here. So, even though these angles are bigger than 90 degrees, all 3 of these are, we can use these triangles to help us find the trig ratios. So, before I move on, I'm going to highlight all my x's here and all my bases. Base comes from the x, length of the base comes from the x. And then all of the heights of our little triangles, which would be called the opposite side, comes from our y. Opposite comes from our y. Opposite comes from our y. And then our radius, we use the formula to find. So I'm going to highlight my formula in a different color and highlight that. Okay, so now we have all the tools to understand these new formulas for sine, cosine, tangent, cosecant, secant, and cotangent that I'm about to give you. So far we only know them as opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. But now we're going to think of them in terms of x, y, and r. So here's what I mean. Sine of theta in terms of x, y, and r is y over r. cosine of theta is now equal to x over r. And tangent of theta is now equal to y over x. And all this comes straight out of these little triangles. If you look at this theta up here, that's what I was talking about at the beginning. And then, of course, your reciprocals are all going to just be the flip of this ratio. So cosecant theta is going to be r over y. Secant theta is going to be r over x. And cotangent theta is x over y. Now, there is one thing that we need to note here. Remember, algebra rules say that we can never divide by a 0. So we need to note, we cannot have x equal to 0, we cannot have y equal to 0, and we can't have r equal to 0. In other words, we cannot have any of our side lengths of our triangle equal to 0. If they do, then we don't have anything. This equation is undefined. Alright, so I'm going to pause the video, let you chew on that for a second, then I'm going to show you some examples.